Yeah, I'd say have it over to you. Feel free, and thanks for joining us today.
Great. Thank you so much for having me. I've been an advocate of DarkSky now for more than 10 years and based here in Tucson, Arizona, at the University of Arizona. I'm a PhD candidate here, actually wrapping up my PhD in a few weeks, which is very exciting. And it's really such a delight to be in the same place as the DarkSky headquarters and be at a place that is truly a special location to be studying sleep and circadian rhythms, given the importance of dark skies for that very reason. So let me go ahead and share my screen with you all. And hopefully you can see that there. I'll try and leave plenty of time for questions at the end. So my goal today is really just to convey the importance of strategically timed light exposure. So thinking about when we're getting exposure to daylight and how that can regulate our circadian rhythms, as well as when we're wanting to be exposed to darkness and how that can support our sleep and our health. Before I get into the slides, I just want to give a shout out for this background image that I use throughout my presentation. So this is an image in the Grand Canyon that was taken by my friends at the Sky Glow Project, Haroon Mehmedinovich and Gavin Heffernan. I highly recommend you check out their work if you haven't already. I've seen some emails, some dark sky emails this week referencing some of their work. So be sure to check out the Sky Glow Project. They have done amazing things to capture the effects of light pollution across the US, as well as just beautiful time-lapse photography. So definitely check it out. Let me advance this one. So I thought I would start out by just thinking about what sleep is, right? And giving a bit of a breakdown. So sleep is this kind of mysterious thing that we do every night, right? Night after night, from when we're born until the end of our lives. But what actually is sleep when we try and think of it in terms of all of these different contexts and all of these different dimensions? So the first thing is really that sleep is naturally occurring. You know, it's a thing that our bodies know how to do, and it's biologically programmed just as we need air to breathe, food to eat, clean water. We need sleep. It is a biological necessity in order for us to do the things that we do every day. And it occurs sort of directly in relation to how much time we're spent awake. So the longer we're awake, the more of a kind of drive that builds up in our brain to encourage us to sleep longer as a result. So it is naturally programmed into our bodies. It also involves some amount of what we'd say is perceptual disengagement. You know, you're not really aware of what's happening around you while you're sleeping. And this is important because sleep is so essential for all these different processes, and I'll touch on some in a little bit. But it's important that it's allowed to be protected. So actually, the deeper that we get into our sleep, perhaps you've heard we have these different sleep stages, you know, kind of cycle through lighter stages of sleep into deeper sleep, and then finally REM sleep, when all those weird and wonderful dreams can occur. But the deeper we get into our sleep, the greater the threshold that's required to actually wake us from sleep. And this is so that we're protected, because there's so many important essential processes going on in the body during sleep. So we have some amount of disengagement from the environment. There are some interesting studies showing that, you know, we actually perceive, particularly through audible cues, a little bit more than we might be aware of. And there's some cool research that's been going on looking at giving people dream cues. So think of a tree and then how that manifests in terms of a tree in their dream. But for the most part, we're actually not super aware of what's going on around us while we sleep, and for good reason. Oh, on. There's also reduced consciousness while we're sleeping, right? You're not able to really be interacting with someone while they sleep. And again, this is because it's protecting what's happening. Protecting. Perhaps you can mute yourself. So there is this amount of reduced consciousness while we're sleeping, right? Or what I actually put in parentheses is altered consciousness, especially when we talk about what's happening during dreams. There are some really interesting things that might be going on with consciousness, which I find endlessly fascinating. There's also immobility while we're sleeping. So it's pretty normal during and non-REM sleep, so non-rapid eye movement sleep, to kind of toss and turn here and there. Maybe as you're drifting into sleep, you've had the experience of what we call hypnic jerks, that kind of feeling like you're falling, totally normal. But actually, when we're in REM sleep or rapid eye movement sleep, our body goes into this state of paralysis. And that's really important because if we're having any weird and wonderful dreams, we don't want to be acting them out while we're sleeping. You can imagine a scenario where you're dreaming about being in a boxing match or something like that. If there's someone in the bed next to you, that can actually be pretty dangerous if you start acting out your dreams. So we have relative immobility while we're sleeping. And then the last thing is that sleep is controlled by what we call homeostatic and circadian factors. So that's a very technical sounding way of saying that we sleep in order to achieve homeostasis. So like I said before, the longer we're awake, the longer our sleep will be to kind of make up for it. And it's actually really interesting how that homeostatic sleep drive, what we call it sleep pressure in the brain, builds up as a result of being awake. So if you've heard of the molecule ATP, it's kind of the energy source that our cells use. As our cells use energy, just being alive and awake and doing things, that A in the ATP, adenosine, starts to build up in our brains throughout the day. And it builds up and it builds up and it builds up. And as it binds to special receptors throughout the brain, it makes us feel sleepier and sleepier. So that's actually the thing that makes us feel drowsy towards bedtime. But also working kind of conversely with this, we have a circadian rhythm. So our circadian drive for wakefulness is greatest during the day. And then at nighttime, we have a circadian drive for sleep. And this drive is really important because let's say you get a really bad night of sleep. I'm sure all of you have had that experience from time to time. You typically find that once you get up and get started and ready with the day, you tend to have a little bit more pep in your step. And this is because we have a drive that kind of keeps us going. We have some amount of resilience after a poor night of sleep because we have to get on with the day, right? But then by nighttime, because you've had a poor night of sleep the night before, your drive for sleep will be really high and you'll feel super tired. So we have these amazing natural rhythms that happen in our body that predispose us to either being awake in the daytime or asleep at night. And sleep is so important for everything. It's amazing that it's being discussed more and more in kind of like the public health space, and that more and more doctors are asking about sleep, because it really does sit at the foundation of everything else. We kind of hear these three pillars of health as being nutrition, exercise, and sleep. But without healthy sleep, it's really difficult to exercise and it's really difficult to eat well. So I'm perhaps biased, but I think sleep is at the root of everything good. So sleep is essential for all of the things. Let me see if I can put my little laser pointer on. There we go. So sleep is essential for brain health. So you've probably heard that at night, we have this special process that happens in the brain that kind of works like a pressure washer or like a convection current that gets ramped up during slow wave or deep sleep to basically flush out all of this like metabolic waste that builds up in our brains over the day. This is really important. And across our lifespan, this helps to protect us from things like dementia and Alzheimer's disease. But also on a more short-term basis, day to day, we need sleep in order to feel sharp the next day, to be able to make good decisions, to be able to have good reaction time. So sleep is essential for us to be able to do everything, all of the thinking, all of the interacting with others that we need to do. On that note of interacting with others, sleep is really essential for our relationships. It's really essential for how we interact with one another. There's been some fascinating research out of the University of California, Berkeley, showing that when people don't get enough sleep, they actually are less altruistic and less generous the next day. And so you can kind of imagine how this might manifest in society. If we have lots of people who aren't sleeping very well, how maybe they'll be less willing to help each other and less willing to be able to engage in sort of rational conversation with one another. So sleep is essential for our relationships. It's also essential for our mental health. I'm sure everyone's had the experience of lying awake in the middle of the night. Everything seems terrible. The next day you wake up and it doesn't seem so bad. we actually have these little rhythms that happen in our brain that predispose us to kind of more positive thinking in the daytime and more negative thinking at night. So being asleep during the night is actually really good for our mental health. But beyond that, sleep is essential for all of the different physiological systems in our body. So our cardiovascular system, it lowers blood pressure, keeps our heart healthy. It's essential for our immune system. If you've ever had the experience of, not sleeping very well, you tend to pick up bugs easier and get sick. If you have any autoimmune conditions, you tend to find that flare-ups happen more often when you're not sleeping very well. Sleep is essential for regulating our metabolism and ensuring that we that we're not sort of hungry more than we might usually be. And on that note, I'm not going to talk about it today, but my particular area of research is in eating behavior and sleep. And we sort of find that when people aren't sleeping very well, they tend to make worse decisions about their food the next day. And you can imagine how if this happens night after night, you might be making really poor choices about your food long term that leads to all kinds of health problems. Sleep is also essential for the gastrointestinal tract, so keeping our gut healthy. People who don't sleep as well tend to have higher rates of things like irritable bowel syndrome and Crohn's disease. So really, it's every system in the body. And I put this little old lady dancing here just to really highlight that one of the best things you can do to age healthily is to be able to be getting enough sleep. So just really prioritizing your sleep. But one of the things that we study in our lab is health disparities. So this idea that some people get better sleep than others. It's very easy to just sort of have this blanket statement, go get better sleep, like go get more sleep. But actually, the many, many facets of why some people sleep better than others really needs better attention from health providers and also from anyone in the public education space. So I've pulled this graphic from actually my PhD advisor, Michael Granner, who's a clinical psychologist here at the University of Arizona, and Fabian Fernandez, who's a brilliant neuroscientist and circadian biologist, also here at this university. And they put a paper out in one of the big science journals called Science a couple of years ago now, essentially just really well displaying in this really like kind of clear, nice, pleasant visual graphic, just how many things go into ultimately how well a person sleeps. So, touching on some of these different aspects of health that I just mentioned on the previous slide, at the individual level, there are so many reasons that some of us get better sleep than others. From underlying genetics, do you have a predisposition to a health condition that makes it challenging for you to sleep? From that, all the way through to everything about how you've been raised, the sort of beliefs you have about sleep. Were you raised by parents who said you can sleep when you're dead, work, work, work? Or were you raised in an environment where it was considered important to take care of yourself and to be resting? So there are all these things that go into just who we are as individuals that dictates kind of the quality of our sleep and the decisions we make about our health. But also, what's happening in your social environment, what's happening in your household. Do you have a new baby in the house that keeps you awake? Do you have a noisy roommate? Do you have a noisy neighbor that wakes you up first thing in the morning? What's the kind of quality of your neighborhood? Do you feel safe where you live? If you don't feel safe, you actually have to be pretty vigilant, and vigilance can keep you awake and make you anxious at night and make it difficult to sleep. So there are all these things happening in our immediate environment, in our social environment, where we work, what our family dynamics are like, and all these things. And then taking one step back from this even further, what's going on in society, right? There are many things that are difficult to control, difficult to feel like you have any power over, but can really weigh on your mind or affect your environment. We live in this 24/7 society now, which has many great benefits, but also is detrimental for our health in many ways. We are all cyborgs glued to our smartphones all day. And then, you can't deny things like wars that are happening in the world, kind of political problems that are happening, and things like climate change. So there are all these things happening at the societal level that all play into our consciousness and our awareness and ultimately our health, whether we're aware of it or not. One of these, of course, relevant for this audience, is the problems we have with this 24/7 society and light and noise pollution. So this was a study that came out a few years ago. I think it was in 2020. And this really just captures it so well, this idea of health disparities and why some people get better sleep and better health than others. What they did here was they looked at racial health disparities in terms of who's most exposed to light pollution at night. And what you can see really clearly is that compared to the national average, where all of these racial groups are pooled, anyone who is Asian, Hispanic, Black, or Native Hawaiian or Pacific Islander, these groups are generally exposed to more light pollution than are white individuals. And this is really one of the biggest problems that we're seeing, that health disparities are rife, and they're kind of at the root of so many problems that manifest in people's lives. So relevant for this audience is these inequities in light pollution exposure at night. So, humans evolved to be diurnal creatures. There are some nuances from person to person. Some of us are more morning people, some of us are more night owls. But for the most part, we evolved to be active and awake and doing things during the day and then asleep at night. That is how we evolved. And the reason for this is actually melatonin, what we call the hormone of darkness. Melatonin is one of the most fascinating and misunderstood hormones. And so I just wanted to take a moment to really explain a little bit more about melatonin and about some aspects of it that you might not be aware of. So melatonin has, it's sort of our oldest evolutionary hormone that we're aware of. It's been around for more than 3 billion years, since single-celled organisms were on the planet, our earliest bacteria. And its oldest evolutionary role is actually as an antioxidant. So before we even think of melatonin as being helpful for sleep, I think most people, when they hear melatonin, they think of melatonin gummies that are going to help them sleep at night. And I'll get into that. But the primary role of melatonin, and the thing that we most benefit from, is actually its antioxidant abilities. So you don't have to be a chemist to just appreciate that there are a couple places in the molecule, such as here and here, that the atoms can serve as electron donors and basically mop up free radicals that are causing trouble in our body. So if you've ever heard of the term reactive oxygen species or oxidative stress or free radical, these are referring to molecules that are causing problems in our bodies. And certain things can increase how many of these we have in our body, things like stress. But for the most part, they're just a natural result of breathing oxygen and just living and being humans and doing the things that we do every day. They're a perfectly normal thing to occur in the body. But this is why we need systems in place to be able to keep them in check. So you can kind of think of these reactive oxygen species as kind of being like ping pong balls that go around the body, and they cause these chemical reactions that lead to cell damage and stress, and ultimately aging. This is why getting vitamin C, vitamin E, lots of healthy fruits and vegetables is so good for us, because they help to kind of go around and mop up these free radicals. Melatonin is another such antioxidant. So melatonin can chelate heavy metals, so it's great for any heavy metal pollution in the body, as well as any of these reactive oxygen species. And so what it does is it goes around every night when it's released, and it mops up all of these free radicals. So melatonin is really, really critical for our health. I love this graphic because it just sort of shows on the evolutionary time scale from very simple single-celled organisms right the way up to, humans now, all the different roles that melatonin has evolved to take on. So it kind of started out, like I say, as an antioxidant. As animals became more complex, it started to become associated with light, or rather with darkness in the absence of light. So it started to play a role in creating circadian rhythms in our earliest animals. And then eventually, as animals started to display what we know as being sleep, or what we recognize as sleep. Not everyone, sleeps. Not all animals sleep under a blanket in a bed at a certain time with an eye mask and all the stuff, but animals all exhibit this kind of sleep behavior where they're immobile, eyes closed, that type of thing. Melatonin started playing a role in sleep too. So it's very interesting. And I just wanted to spend a moment just so you can appreciate just how important melatonin actually is. So the way that melatonin actually works, or the way that our circadian rhythms actually work, is actually pretty fascinating. And so this is kind of like a circadian rhythms 101 for you to be able to appreciate how light pollution stands to be such a problem in terms of healthy melatonin secretion. So we have a master clock in our brain, and it's called the suprachiasmatic nucleus, or SCN for short, and it's found in the hypothalamus. And this you can think of as like the conductor of the orchestra of all of the clocks in your body. So we have these amazing little genes in every cell in the body that oscillate on about a 24-hour basis. For most people, it's slightly longer than 24 hours. So it's not exactly the same length as the solar day, but it's around 24 hours. And these cells are found in all of our different organs, all of our different tissues, but they rely on input from this master clock in the brain so that they're all doing things at the same time. You don't want your liver thinking it's daytime and then your gastrointestinal tract thinking that it's nighttime. So you kind of want everything working in synchrony. The way that this clock in the brain is able to tell what time it is, or time, roughly thereabouts in the solar day, is using light entering the eye. That's really as simple as it is. So there are special cells in our retina. You've probably heard of rods and cones that are part of the visual system, but we also have these other types of cells, and they're called intrinsically photosensitive retinal ganglion cells, which you don't need to remember. But these other special cells at the back of the eye that use light entering the eye. At one time, it would have been sun, but now it's other things like artificial lighting, entering the eye and activating a little pigment that's found in these cells. That pigment's called melanopsin. They actually respond specifically to blue light. So I thought I would change these to blue so it's a little bit more representative. These cells are activated by light that's about 450 nanometers. So just putting this here in the visual spectrum, blue light wavelengths come in, activate this little melanopsin pigment, and this basically tells this clock in the brain, it's daytime, it's daytime, it's daytime. So this is great, right? In the daytime, it's a very wonderful system. And then in theory, at night, this light is no longer entering the eye. This melanopsin pigment is no longer activated. And then the brakes kind of get taken off on the master clock, and the master clock is told, okay, it must be nighttime because there's no light entering the eye. What this does is it starts a little cascade of things in the body that help to get us ready for sleep. One of these is that it starts the secretion of melatonin. So tucked just under here, kind of covered by this, but right under here is the pineal gland, which you've probably heard of before. So the pineal gland is where melatonin is secreted from. We also have melatonin that is produced in several other parts of the body, including the gut and the skin and a few other areas. But the main bulk of melatonin, especially as it's related to our circadian rhythms, is actually produced in the pineal gland. And so what happens is that every night, melatonin gets made fresh. It's not stored in the pineal gland, it gets made fresh. It comes from the amino acid tryptophan, which is found in lots of different foods. Tryptophan goes through a series of steps, including the conversion to serotonin before eventually getting converted to melatonin. So melatonin comes from serotonin. And what happens is once this light is no longer entering the eye, melatonin gets released from the pineal gland, and it just starts to get released into our bloodstream, and it trickles across the course of the night. It'll start this process typically if there's no bright light exposure before bed. It'll start this process about an hour or so, hour and a half, before we start to feel like really sleepy. And it will continue being released until about halfway across the night. So halfway through your typical sleep period, it'll reach its kind of maximum, and then it will slowly taper off until morning, at which point you'll wake up, start your day. And melatonin's amazing because it can actually go, it's very lipid soluble, so it can travel through into all of the different cells of our body. It binds to our blood vessels and lowers blood pressure, which is really healthy for our cardiovascular system. It's been shown to improve gut health in people, like I say, people at risk of irritable bowel syndrome and Crohn's. It can help with gut health, but it also binds to many areas throughout the brain that essentially quiet the brain and help to promote sleep. So, the kind of typical chatter that you have in your brain all day, thinking about this, that, and the other, melatonin works to kind of quiet that so that you can drift into sleep. Because if you've ever had the experience of having trouble sleeping or any mild insomnia, you'll know that it's really difficult to sleep if your brain is in overdrive. So one of the things melatonin does is it starts to kind of quiet that process in the brain. So it's a really beautiful system that I hope you can appreciate. It's this amazing molecule that we have that protects our cells, prevents aging, and does so many different things to not only improve sleep, but improve all these different tissues and organs throughout the body. The problem is, though, that, of course, we live in this 24/7 society, right? So, on the one hand, we have shift workers, so people who are doing many of the essential services that sometimes we take for granted, our healthcare workers, firefighters, police officers, etc. And it's difficult to gauge what percentage of the population this is. Some estimates are around 25%. But we sort of think it might be up to 50% of the population who are living a shift work-like lifestyle. So people who are routinely being exposed to light at night, who aren't necessarily working a shift work job. And this is, anyone who's had a baby, you'll know that you have to be up when the baby's up and sleeping when the baby's sleeping. Babies don't have a consolidated circadian rhythm for the first couple of years of life. And so mom or dad has to get up and be helping the baby throughout the night. They kind of become a shift worker in their own way. We also have, people who are up late night studying for exams, anyone who's up late night partying, and then the millions of us who are traveling. There's more of us traveling than ever before. And you think about all these different scenarios, there are, a significant portion of society who are not having this lovely sleep pattern every night that is working in harmony with the solar day. And this is a pretty big problem. So since 2007, the World Health Organization, CDC, adopted the statement that shift work is a probable carcinogen, which sounds really scary. And don't worry if you are a shift worker, there are lots of things you can do to protect your health. But because of chronic melatonin suppression that typically happens if you're working nights and being exposed to all that light at night, there are lots of things that can go wrong in the body. We can have our immune system starts to get a little bit crazy. We start to get a little bit more inflammation than we might have if we were sleeping at night. We can have things go a little bit strangely again with our metabolic system, as well as some of these other things that go on. Just the general state of inflammation that can happen in the body. There are lots of things that people can do to be able to support their health, though. So, if you are working shifts, one of the most challenging shift patterns is what a lot of nurses work. So if you're a nurse, you'll know you typically work rotating shifts where you're constantly changing your schedule. That can be really challenging because your body doesn't get to adjust to anything. But there are many things you can do, like exercise and eat well, and, cut down on smoking and drinking if those are vices and things like that. To be able to support your health, there are some steps you can take, but this is one of the problems that we do have in society is that many shift work jobs are essential, and we need to figure out how to help people. I wanted to give a quick nod to some research that's been done in melatonin and children. Children are not shift workers, but they are uniquely vulnerable to light at night. So this was you may have come across some of these headlines over the last year or two talking about the increasing problem with children being given melatonin supplements. This was a headline that came out from the University of Colorado at Boulder. There's a brilliant melatonin, pediatric melatonin researcher named Dr. Lauren Hartstein. She's actually just joined our faculty here at the University of Arizona, which is very exciting. But she's done a lot of research looking specifically at exposing children to light at night and looking at their sleep and their melatonin profiles. What she does when she performs her studies is she goes into families' houses and she'll make everything dark. So she'll try and cover all of the windows, all of the light emitting devices, to have them be in what is like a truly dark environment, but in the safety of their own home. It takes a lot of effort, a lot of time, but she's found some really cool findings as a result of doing this. So I wanted to highlight one of the studies that she did a few years ago now, but she's replicated this data since. So what this is essentially showing is a protocol where she had children wear a wrist-worn device, so kind of like a Fitbit or a smartwatch that tracks their sleep. She has them wear that for a week under their normal conditions. So whatever the parent deems to be their, bedtime and wake time. Then she has them be exposed to nearly total darkness. So, the children can still see enough by candlelight, etc., to play games and have some interaction, but there's no bright artificial light for it starts sort of halfway through the day typically, and then it will go on until the following night before bed. So she goes in, she covers all of the windows, covers everything, and then she has the children play games, do things, but go to bed and have melatonin profiles that replicate what would happen if they were out in the wild, maybe just surrounding a campfire and not having any of this light pollution at night. The following night, after having the night of complete darkness, she has a really quick flash of light. She exposes children to light in the hour before they typically go to bed. And what she's done is she'll measure their melatonin. You can measure it in saliva. She has the children chew on these little sticks, and she tests how their melatonin profile looks. What she's shown here, this is showing hours from bedtime, so 0 being bedtime. And then here on this axis, looking at melatonin, this is picograms per milliliter, so very, very, very small. That's how much melatonin is secreted in our bloodstream at any one time, which, by the way, is much lower than the melatonin that's found in supplements. What this is showing is the natural melatonin rhythm when the children were exposed to darkness. So when she goes in, she covers all of their windows and she observes what their melatonin profiles naturally like. What you find is from about an hour before bedtime, their melatonin starts to rise, and then it keeps increasing as they go to bed. That's normal. That's what should be happening. When she exposes them to bright light that suppresses their melatonin, you can see that there's no melatonin secretion. And then even after the light has stopped, it's still suppressed. So this is really problematic. And, there's a reason that many parents are looking for sleep aids for their children. And there's a big reason that there are so many melatonin gummies on the market that are targeted at children, or, being marketed towards parents to be able to buy for their children. The problem that we see, though, is that hospitalizations for suspected melatonin poisoning in children have gone up by about 500% in the last few years. And it's a really big issue because the supplements that you get on the market are way, way higher than what our body's actually producing. And what you're seeing across the night, like I say, you have this typical melatonin profile that starts before we go to bed, continues till halfway through our sleep episode, and then it trickles off. These supplements are essentially like a massive spike that happens as soon as you take them. And so it's what you call supraphysiological. It's beyond what's happening in our natural physiology. children are uniquely susceptible to light pollution at night because our lenses in our eyes, not in glasses, but our actual lenses in our eyeballs, are very clear when we're children. And they become yellowed with age. That kind of protects us a little bit more in adulthood against light pollution. But children are very, very vulnerable to light at night. And so this is one of the reasons that we see this kind of pattern in children. And if you have kiddos at home, it's something to think about in terms of if they are having sleep problems, they're not tired when you want their ideal bedtime to be, maybe think about how much light you have around the home, because that might be one of the best ways of being able to support their natural melatonin rhythms without having to rely on a gummy that provides such a high dose for them. Melatonin, because it is a hormone, is implicated in lots of different areas of the body during puberty. And so it's actually not recommended by sleep experts that children be taking melatonin. So I put this in here. Two roads diverged in a yellow wood. This is sort of a black and white wood, but that's okay. And what I really mean by this is just that we find ourselves as a sleep and circadian rhythms field, but also as a society and as anyone who's interested in light pollution, we find ourselves at a bit of a fork in the road, because on the one hand, we really want to be doing what we can to reduce light pollution at night and helping people get better sleep and have healthier melatonin production. But also, there are many essential roles, like I mentioned, shift work roles in society that do require that we kind of offer some support for those people. Things are becoming automated, but the role of a surgeon, the role of a nurse, these things aren't become automated anytime soon. So we need to be able to support these people. So I thought I would throw a little bit of an action plan up here, just because, of all of the people in the audience here, you all have different skill sets, different areas of expertise. There might be something on this list that you can get involved with in addition to, dark sky advocacy in your communities. And so I thought I would put this up here just as food for thought for people. The first thing we need to do is to help shift workers. So shameless plug just for the work we're doing at the University of Arizona. We have researchers here helping firefighters, helping military personnel, helping anyone who suffers from suicidal ideation, or my research focused on eating behavior, lots of different dimensions of shift work. We really need to be helping these people who are some of the more vulnerable people in society. So, and especially in terms of health disparities here and looking at why some shift workers get better health than others, super important. The other thing, don't need to say it because I'm preaching to the converted, but really reducing artificial light at night. If you are not a shift worker, if you're able to have the luxury of sleeping at night, then do what you can to absolutely advocate for darker skies where you live and also have darker light in your home. And I'll share a few examples on the next slide, I think, just about some things you can do in your own home. Interestingly, and this is not talked about enough, it's been shown that the amount of daylight we get during the day affects our melatonin secretion at night. So it's not just the case that you want to make sure you're having, dark exposure at night, but actually it seems to be the case that going outside in the morning, getting daylight and getting daylight during the middle of the day, it can kind of serve as a bit of a buffer against some screen use at night. Many of us watch TV at night or using a tablet or a phone or computer or whatever. You don't need to panic and be like, shut off all screens, I need to sit in complete darkness. That's not exactly how most of us spend our evenings. But one of the things you can do to protect yourself is to make sure you're getting enough daylight exposure during the daytime. It sends a really powerful signal to our brain that it's daylight and kind of starts a bit of a timer going so that even if we have some light exposure at night, we'll still be able to get into that healthy melatonin rhythm. So promoting more time outside is super important. We also need flexible working schedules. Everyone has a slightly different preference for when they like to wake up. And if we're making everybody wake up with an alarm clock every day, we're cutting sleep short for a lot of people. And so I think if you have any ability to change work schedules in your workplace and encourage flexibility, you really get the best out of employees. You know, this has been shown time and time again that when people can work at times that they feel most switched on and most engaged, you get more work done. So flexible work schedules, definitely better for our circadian rhythms. School start times are a huge one. There's a really big push in the sleep and circadian rhythms field to try and get school districts to start school later. You may not know this, but when we transition from childhood to adolescence, our body clock shifts later. So this is why if you have teenagers, or if you remember being a teenager, you'll know that, you know, in this age range, typically people go to sleep later, right? Teenagers want to stay up late and they also want to sleep in the morning. Teenagers get this reputation of being lazy, or just, you know, I don't know, getting up to mischief at night. That's really not the case at all. It's biologically programmed into adolescence until you're sort of mid-20s or so to have a later body clock. And this just isn't understood. We don't really know evolutionarily why that's the case, but it is in fact the case that our body clock shifts later and then it shifts earlier again as we get into our late 20s and 30s. But basically making our children wake up to get the school bus at 6 in the morning is the equivalent of making an adult wake up at 3 in the morning. And so oftentimes those teenagers aren't tired until midnight or even 1 a.m. And if they're only, you know, if they're having to get up at 6 in the morning, they are being chronically sleep restricted. And this is a huge problem for development, for their ability to learn, and also their mental health. And I think it's no coincidence that we're seeing such mental health problems in young people today. I think a lot of it comes from not having the ability to get enough sleep. So if you're on a PTA, if you have any say in your school district, definitely look into the initiatives to be able to delay school start times. There is a big push to try and abolish daylight savings time. I'm always happy to chat about this more with people, but the transition to and from daylight savings time is terrible for us. Our body doesn't know that the time has changed. It's just very confused. And this is not good for our circadian rhythms. So I can always provide people with resources for things if they want to read up a little bit more on this. We need more education for kids about light pollution and circadian rhythms, and also in medical school. In most medical school programs, physicians-to-be are not trained in other than the basics in terms of the depths of sleep and circadian rhythms and how they really affect everything else in our body. So we're really trying to push that so that there's more training. And then a little ambitious, not a quick fix, but we need better infrastructure and architecture and lighting systems so that offices are better lit, so that homes are better lit. You really want to maximize daylight exposure in the day and darkness at night. So these are just some things to think about. The expert recommendations, as they currently stand, are that we want to be exposed to a minimum of 250 lux of what we call melanopic EDI. So this is light in that, this should be shifted a bit more, but 450 nanometer range during the daytime. We want less than 10 lux of that blue light at night or in the evening, and then we want nothing at night. This is kind of the expert recommendations for how we should be exposing ourselves to light throughout the day. These researchers, it was a huge panel of experts. They found after doing some field experiments that most domestic homes, the evening light exposure hovers around 30 lux rather than what should be 10 lux. So most of us are exposed to too much light in the evenings and at night. Oftentimes, if you're buying bulbs for your house or for your office, you don't see things advertised as melanopic EDI, but you can consider Kelvin, which is a kind of range of warmth levels about your light. So anything that's a higher Kelvin is more daylight, going to have more of those blue light wavelengths, and anything that is a lower Kelvin number is going to be warmer light. So in the day, you really want bright daylight exposure, and then at night, you want warm tones. A few FAQs that some of you might be wondering about before I open this up for questions. So I get asked about screens and blue blocking glasses a lot. If you have blue blocking glasses that look like this, They are clear with maybe a nice little blue tint on them. I hate to break it to you, but they don't do anything. We conducted a study in our lab a few years ago, and we compared 50 pairs of glasses that were available on the market. And what we found was that unless the glasses were orange or red tinted, they basically didn't do anything. Some of them actually enhanced how much blue light could get through. So it's a real shame that glasses like this are marketed to people. Maybe they do something to improve eye strain if you're looking at a computer, I don't know. But if they're clear, they're not blocking any blue light at night. Like I said, in terms of screen use at night, you want to make sure you're getting enough daylight that can kind of protect you from any screen use at night. But I personally use blue blockers. I find in the evening before bed, it just kind of softens things. So they can be very helpful for people. The other end of the spectrum, there are a lot of people in kind of the podcast space now, the health space, talking about, recommending morning sunlight. It's absolutely important. Definitely try and get outside in the morning if you have light where you live at that time of year, and also during the middle of the day. That's really helpful. Ideally, if you can get out in the evening as well, that helps to send different types of light cues to your brain throughout the day. So get outside as much as you can. If you live at a high latitude in the winter months and you are unable to get daylight exposure, SAD lamps, seasonal affective disorder lamps, those light boxes can be really helpful. You turn them on when you wake up and you're getting ready, and they help to send a really important signal to your brain and help with serotonin, which is that feel-good, happy hormone. So definitely those are useful. In terms of some lighting options for your home, this company doesn't pay me to say this, but Nanoleaf are a really good company that have color changing bulbs, as well as some nice little other circadian friendly lighting style options. What we do at home is we connect color changing bulbs to the Apple Home Kit. So you can have all these different light settings so that it's more bright in the daytime and more red toned at night. There are definitely lots of options out there. An even cheaper option is just to get a couple, allocate a couple lamps specifically to red toned bulbs and just use those as your bulbs at night. There's also a bulb that I travel with everywhere I go. It's called the O Bulb O Pro, and it's a color changing tiny little light. Hotel lights are often terrible. Very few have dimmer switches. They're always too bright in the evening. But this is a great option because this little bulb has a red light setting. So if you want to have some light on when you're unwinding for bed, this is like an option. So I always recommend that to people. And then finally, melatonin supplements. So, like I said earlier, not recommended for children because they can interfere with some of the processes that happen during development. For adults, they are not recommended as a sleep aid. So if you are struggling with insomnia, for example, melatonin is actually not the best option for you. And I'm always happy to chat about sleep disorders and things with people. But melatonin can be helpful for people if you're experiencing jet lag. So if you are traveling across multiple time zones and you're getting to a place where it's their nighttime, but you're still on daytime mode, taking some melatonin there can be useful. The recommendation, though, is to start with about 1.5 milligrams and then work your way up in 0.5 milligram increments. But everyone's different. Some people feel really groggy with melatonin. Some people have weird dreams. So it's always best to kind of speak to your physician if you're considering using it. I will say that melatonin production decreases as we get into older age. So there is some evidence that maybe it's beneficial in older adults. But for the most part, the very best approach is to just support your body's natural melatonin production rather than using these supplements that oftentimes aren't actually what they say on the bottle and are not naturally what's happening. They don't kind of support our natural rhythm across the night. So I just thought I would mention that. So always happy to chat more with people. That's everything I have for you today. That's my email address if you want to email me about anything. And I'm pretty active on Twitter or X, whatever we're calling it now. So I've just put my my profile there if you want to contact me on Twitter. But I'll turn it over to questions and happy to answer any.
Thanks, Kat. That was wonderful.
Yeah.
Really great talk. I know I learned a lot. And folks, we'll give you a second. You can write down her email if you'd like to send more questions before we get to Q&A in the chat. But do appreciate your talk today, Kat. I know I learned a lot. And folks, if you do want to take your time to submit any more questions, please feel free. We'll start the Q&A portion. And you can also check out this recording on YouTube following the live event. We'll have that up in the next day or two. So yeah, Kat, I think you kind of answered some of the questions already. You're well prepared FAQs. I think if, we got a lot of good comments coming in about those action plans or the action points. Would you mind just kind of going over those once more? And I think those were
Yeah.
just great steps to follow. Yeah.
Yeah, let me share this one again. Action plan. Yeah, I always think it's great to appeal to an audience that has, so many different awesome people doing great things in different areas, because there are lots of things that you might be able to do in, your community. And, if you have any say, like I say, in the school district, if you have any say in a workplace, if you have employees of your own, maybe you can think about increasing flexibility. So yeah, these are all of the different things that I put up here. There's some people doing great research wanting to think about how to, and it sounds very kind of futuristic and utopian, but better build our cities so that we're not blocking out sunlight at all during the day, just because it's so helpful for that important daytime signal. So yeah, lots of things we can be doing.
Wonderful. Thank you.
Yeah.
There's another question. Could you recommend, I'm sure you could, further reading or listening in on circadian rhythms?
Further reading and listening. Yeah, I mean, there's several different podcasts. The Sleep Research Society, they do lots of different podcast episodes about, interviews with different scientists talking about things. But I would say there's some really good books. There's a book, what's it called? Let me see if I can find it. See if I can share it. It's by Wally Mendelsohn. And it's called The Science of Sleep, What It Is, How It Works, and Why It Matters. And that's, by Wallace B. Mendelsohn. That's a really great book to start. It's got lots of images in it, and it tells you all about how sleep works, different sleep stages in the brain, things like that. That's a really good, easily approachable book. But I can always maybe put together a list of some other resources. I'm always happy to share that.
That'd be great. Thank you.
Yeah.
Yeah, getting a few more comments in here. And folks, even if we don't get to it, please feel free to post it in here. We can follow up after the live chat. There was another question. Well, I liked this one. Jason asked, how do we go about abolishing daylight savings time? That's a separate meeting, I think.
Yeah.
Topic here, but
Yeah.
you in the chat today, you didn't mention cancer rates, which might be a controversial statistic. Is there anything you could speak to about that correlation?
So yeah, cancer rates are definitely so basically for anyone who is a shift worker, there are elevated rates of things like type 2 diabetes and kind of metabolic dysfunction, as well as cancer. So one of the things that I like to look at when I'm thinking about pulling any statistics are what we call meta-analyses, which is basically a way of analyzing data from many different studies to increase the sample size to kind of improve statistical power. And so there have been a few of these big meta-analyses done on breast cancer in female nurses and on prostate cancer in males who work night shifts. And some of these are conflicting. And I think the biggest problem that happens is that when you're pooling data from lots of different studies, then if all of these studies have collected their data in different ways, it can be really difficult to sort of standardize and say that all these data are sort of equal. So the way that I sort of look at things is that yes, there is good reason to think that cancer rates are higher in people who work night shifts, but because there's so much variability from person to person in terms of their lifestyle, other things going on, their genetic predisposition to things, it's not necessarily the case that because you work night shifts, you're going to get cancer or you're going to get any of these bad things. It really depends on so many other things happening in your life. And, you know, what is the underlying stress levels in your life, your family environment? Can you sleep during the day when you are offered the opportunity to do so? Or do you live in a really noisy place where you actually can't get very much sleep during the day? There are so many nuances, but it is clear that melatonin is very beneficial in not only being able to prevent cancer, but also it's been used in some studies as an adjuvant therapeutic during chemotherapy. So melatonin is definitely helpful for preventing cancer and also helping with some of those negative effects that can happen during chemotherapy. So yeah.
That's very interesting. Wow.
Yeah.
Thinking back to earlier parts of your presentation today, I need to forward this talk to my teenage girls. And
Yep.
just part of it's I'm sorry, part of it's like understand what's happening to you. That's great.
School start times. I think we definitely need to be helping our teenagers to sleep longer.
Definitely. What is there studies or what information can you share any with melatonin production related to ADD or ADHD?
Oh, that's interesting. I actually don't know. I haven't looked at that before. Yeah, I could definitely, yeah, it makes me wonder now. Can definitely have a look and see. I have no reason to think that it would be any different, but I don't know if there's any, you know, if you're using any stimulant medications or anything, I don't know if there'd be any kind of changes in melatonin production associated with medication use for ADHD. But in terms of, you know, the brain with ADHD versus the more neurotypical brain, who knows if there is such a thing as neurotypical, but yeah, thinking about that, I'm not sure. I don't have any reason to believe they would be different, but I don't know. That's interesting. Good question.
Great. That's great. And just want to remind folks to check out our YouTube channel for all the other talks we had this International Dark Sky Week. And I think we'll take one more question, then we might wrap it up today. And Kat, thanks again. And folks, thanks again for joining us.
Yeah, thank you
With
so much.
children and melatonin, obviously we want to get them outside and with the sunlight. And then adults, what do you think about adults using melatonin? I know you mentioned that. And the second part of that question was, are these blue light filters, really enough?
Mm-hmm. Yeah, so you know, in the sleep field, I would say it's pretty divided. Some sleep researchers, circadian rhythms researchers, use melatonin themselves, either nightly or specifically when they travel. Other people say, no, 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 the supplement industry is not regulated. You can't trust any of these things. You know, I'm from England, and you can't buy melatonin over the counter in England. So in many places, because it is a hormone, you know, in many places you do have to get it on prescription. It is, you know, it does have some benefits by taking supplements in these scenarios where, you know, like I say, with jet lag, you want to try and adjust your body clock. I personally don't supplement with melatonin. I prefer to support my body's melatonin, but I think the real evidence might be in older age, just because as we get older, we do produce less of it. So it might be beneficial for some older people, but I do think that you don't want to be taking the 10 milligram doses. There was a study that came out last year finding that most of the supplements, they went and took many popular supplements available on the market, melatonin supplements, and they found that nearly none of them had the actual dose they said that they did on the bottle in them. So it's just something to bear in mind, that what you think you're getting might not actually not be what you're getting. It might be higher, might be lower. So yeah.
Yeah, no, that's great.
Oh, and your question about the blue light filters. I mean, yeah, I think if you're getting enough daylight, I don't encourage people to be really panicky about screens at night and sort of be hyper controlling about it, because that can be stressful. I just think generally try your best to get as much daylight as you can during the day, because it really does protect you at night, and it encourages, you know, maybe a bit of movement and some fresh air during the daytime. But if you are ever in doubt, some people are more sensitive than others to light pollution. That's been shown. Some of us can have overhead lights on and we're not at all sensitive to it. Some of us are very sensitive to even the littlest bit of light. If you suspect that that is you, try some red or orange tinted blue blockers. That can just be a helpful thing.
Great. Great advice. And I know this crowd will eat that up, so that's perfect. Thanks
Yeah.
for all your wonderful information and presentation today, Kat. Folks, if you do want to learn more about Dark Sky Week or the Dark Sky International Organization, visit us at darksky.org. Thanks again for joining us during International Dark Sky Week, and you can check this conversation out on our YouTube in the coming days. So thanks again, Kat, and thanks folks for joining us. Hope you have a good one.
Thanks so much. Bye.